All right, here we go. Day 4 of e-learning. So, hi guys. I was already at school when they called it, so I was working on other stuff. I have a sub tomorrow, so I'm getting some stuff ready for that. We're not doing our lab today, obviously. Since I won't be here tomorrow, we'll do it Wednesday. Okay, I've pushed the test from Thursday to Friday since we have one more less day of in-class instruction and opportunity to work with you, asking questions and doing the lab and doing some other things. Okay, so I rearranged the study guide and the review questions and stuff, and so today's homework is going to be pages 110 and 111. And the reason I say page 110 is it's the review of the main concepts. You really should read through that. A lot of you aren't doing that when you go to do the study guide page. And the study guide page tells you that for that concept map on the bottom of the page, you can only use the information on the previous page. So read through that, because I read through it just to see what all was there, and it's a really good review for the test, for the chapter test. So if you look through that, there's additional information on the chapter test, but if you know the stuff on page 110, you're going to do pretty well. There's some additional stuff, like I said, that you need to know, like who was Mendeleev and who was Moseley. Do you remember who Mendeleev was? He created the first periodic table, the first system of the periodic table using cards. Remember, he wrote all the information on cards. There were approximately 60 elements known at that time. Now we have 100. Well, we have synthetics too, which make it up to 118. But naturally occurring is not 118 because there's so many synthetics. So anyway, Mendeleev created it using the 60 known elements. By the way, at the time that he created his table, they did not know about the noble gases. There hadn't been a discovery of the noble gases yet. So, and that's because they don't react. They're non-reactive, where you have alkali metals, and I am going to attach that one of the videos that I know of where you can see how highly reactive they are just in water. And it's not the water so much as it is the oxygen molecule or the oxygen atoms that are in the molecule of water. They're reacting mostly with the oxygen. Oxidation is a big thing with metals. They get a little crazy with oxygen. You know how copper turns green? Oxidation. Iron turns orange? Oxidation. It's from the oxygen, okay? So alkali metals are group 1, highly reactive. Hydrogen is not a metal. It's a non-metal, but it belongs in that group because of the electron configuration. I told you we're going to talk about that later. We'll start that on a week from today on Monday. I pushed that back as well. So they're highly reactive, and they're a group because they have similar properties. Remember, periodicity is about a pattern of properties moving across the periodic table. And I keep saying that metals, strong metallic properties. So what are some of those metallic properties? Well, ductility, the ability to make wires out of it. Most metals are ductile. Malleability, you can hammer it and form sheets out of it. So aluminum foil, aluminum, or as the British would say, aluminium, is on here. And I'm blank right now where he is. Well, maybe you guys can see aluminium, aluminum. Oh yeah, malleability, ductility. Conductivity is huge. They conduct electricity and they conduct heat. So, you know, we talked about how you don't want to leave a metal spoon when you're heating up your soup on the stove and then pick it up. Ouch. because it's conducting the heat from the stove through the liquid into your hand. So don't do that. So conductivity. So as you move across the periodic table, all those properties are strongest in this area, and they get less and less as you move across, because as you move across, you become less metallic. You have less metallic properties. So when you get to the metalloids, you have a mixture of non-metal and metal properties. So when I say that, most of it has to do with that conductivity. It changes when they can conduct, because when you get to the non-metals, they are actually the opposite of conductivity. They're insulators. They stop the ability of conductivity. So argon is a gas, a noble gas, and it's a non-metal, and they'll put it between window panes as an insulator. You can still see out your window, but it insulates the window. It doesn't allow the transfer of heat. It doesn't allow the heat to escape your home in the winter, and it doesn't allow the hot heat outside through your house. Okay, now that doesn't include passive solar radiation. That's a whole nother game. That's a whole other story. But argon is an insulator and stops conductivity. So they're like the opposite of metals. That's why they call them non-metals. And that's why as you move across the periodic table, you have strong metallic properties, including conductivity. And then you get to these that are metalloids, and guess what they call those? Semiconductors. And the reason that they're called semiconductors is that they can only conduct when they reach certain temperatures. And so they're in your electronic devices and everything, because that helps us with conducting of energy through your electronic devices. One of the most, the most abundant semiconductor or metalloid, the most abundant metalloid is the semiconductor silicon. And we've talked about silicon, but I'm reminding you, silicon is the most abundant, and we use it a lot. And we don't just use it in our electronic devices. It's used, it's in the formation of sand. It's used in some glassware. It's used in some plastic wares. It's used in some of the plastics, like the tubing. If you have a fish tank, the tubing has silicone in it. Doctors and stuff, when they have those masks and the tubing and stuff, that's not just plastic, it's got silicone in it. I personally don't purchase plastic bags for putting my leftovers or putting my snacks in, and maybe some of you have even seen, I have silicone reusable bags. They're made out of silicone. So silicone is the most abundant. It's part of the metalloids. It's the most abundant metalloid. It is a semiconductor, but it has a wide variety of usage besides just in your electronic devices. So silicon is right here, okay? Silicon. All right. What else did I need to go over with you? Alkaline earth, they're still highly reactive. They're just not as reactive as these guys, but they're still highly reactive. Another group of highly reactives, but they're not metals, they're mostly non-metals, would be your halogens. They're highly reactive, and we're gonna be starting why next week. It has to do with electron configuration. So the halogens are highly reactive non-metals. If, for example, if you take an alkali metal and mix it with a halogen, you get a really super good bond. I have an example of one that you know. If I take sodium from group 1 and I mix it with chlorine from group 17, I get sodium chloride. It's a really strong bond. So when you mix an alkali metal with a halogen, you get a salt. Boom. If I take potassium and mix it with chlorine, that is also a salt, potassium chloride. Some of you, if you have water softeners, you might be familiar with potassium chloride because some of you probably use it in your water softener instead of sodium chloride. All right, so we reviewed those. We reviewed the properties of metals. We reviewed location of the groups that you need to know, alkali metals that are highly reactive, alkaline earth that are highly reactive but not quite as reactive as these guys. Halogens are group 17, highly reactive. Noble gases are group 18, not reactive. Mendeleev created the first periodic table using the average atomic mass. There were about 60 elements at the time that he created that table. Moseley came along and tweaked it and said, you know what, we can fix this pattern that we see that's a little bit off with the physical property of metal pattern, the periodicity. We can fix the problem that occurred here, and there's other places that it occurred where the mass put them in the wrong group. We can fix that if we go by atomic number. So that's what they did, and it fixed it, and that's the current periodic table. It's by atomic number, and Moseley did that tweak. The two series down here, lanthanide series, they actually lanthanides would shift up here. If you look at the atomic numbers, it would shift right here, and it would be in period 6. And actinides would shift right here, and it would be in period 7. Okay? You just need to be aware of those down on the bottom. We don't do a lot with those. That's high school. Groups 3 through 12. So then technically, well, based on a lot of science groups, they technically are part of the transitions because they fit up in there. Groups 3 through 12, and that's why they're colored the same. 3 through 12 are your transitions. Groups 3 through 12. Some of you missed that. I think you just weren't careful on the activity that you did Friday. 3 through 12. So if you put that it was a transition and it was group 14, that's not true. If you put that it was in group 5, but you put that it was an alkali metal, that's not true. Group 5 is in the transitions. It's right here. It's between 3 and 12. If it's alkali, it's in group 1, end of story. It can't be in any other group. All right. I think that was some of the stuff from just checking to see what else you might need to know. I think I've got you good to go for your assignment. Yeah, I think I got you good to go. All right, so again, your assignment is going to be to look at page 110, review, use it as a review before you start page 111. All right, then you're writing your answers on page 111, either in Notability and send it to me in PDF, or on paper. The paper has your name on it. And you do have to draw the concept map at the bottom of the page, 111. And remember, if you want to check your answers, you can do that online through the interactive concept map. The directions for the concept map say copy this concept map, and then use the vocab terms from the previous page to complete the concept map. The vocab terms, the only terms that you can use down for that are in the yellow. Those are the only terms you're allowed to use when you do your concept map. The ones in the yellow. It's the only ones you're allowed. So if it's not on that page in the yellow column, don't use it. It's not an answer, all right? For 1 through 5, just write the word that would fill in the blank, all right? So that is your assignment for today. And then reach out to me if you have any questions. Oh, I do have a periodic table pen for you today, and maybe you've already looked at it and tried to solve it. I talked a lot about this element today. A goofy convict. A goofy convict would be called a goofy. So you're thinking, what's another word for goofy? Convict. What's another word for convict? Or what's the shortened phrase for convict? Pause if you don't want me to tell you. It's a silly con. Silly con. Goofy. Convict. Silly con. Okay. That one was fun. I just had fun with that one. Okay. You know the drill is you start a new page. Start a new page for today. Today is February 7th. Start your new page, and then your answer will be silly con, and then write the pieces of information. There he is. He's a middleoid, the most abundant. Write your information that you're supposed to write in the order that you're supposed to write. Okay? I'll see you Wednesday, I hope.